Calculus is the maths that explains how a car speedometer needle moves and how far it has really gone. Today we will see how limits, derivatives and integrals describe that motion. Then try a quick practice together. First, picture your speedometer stuck at 30. A limit asks what value the needle approaches as time gets closer to 1 instant. A limit is the value a function homes in on, even if it never quite touches it, like the needle aiming but not jittering. Next, the derivative is the slope of the distance time graph at that instant. So it gives exact speed, not an average. To get it, we shrink a tiny time interval, measure the rise over run, and let the interval head towards 0. The slope we land on is the derivative. For example, if distance equals 3t squared meters, the derivative 6t tells us the speed in meters per second at any t. At 2 seconds we plug in and get 12 meters per second. That is the exact reading the speedometer would show. Now flip the idea. If we know the speed at every instant, how do we recover the total distance? The integral is the area under the speed curve, so we add up infinite thin rectangles of speed times time. Using the same speed 6t, we integrate and return to 3t squared, proving distance regained matches where we started. This back and forth between derivative and integral is the fundamental theorem of calculus. Fundamental Theorem of Calculus. Try this. A raindrop falls with speed 9.8 meters per second. Integrate from 0 to 3 seconds to find how far it falls. You should get 4.9 times 3 squared, about 44 meters. Check that it makes sense for a 3-story drop. Limits let us pin down instants, derivatives give exact rates, and integrals total the change. Master these 3 ideas and you can read any moving world story. From falling drops to orbiting satellites. Generate your own educational videos for free at eduvids.vercel.app.